All right, good morning, everybody. This is going to be our last Friday help session. The next Friday is when finals begin, and there's no way, God's green goodness, that we're going to find a room. So this is going to have to be it. However, I will still have office hours all the next week, so if questions arise, feel free to drop by. We're not going to cover any new Excel functions, with the exception of one. I'll show you one more function. Hopefully, what we put together the last 2 weeks, you guys will be able to use, and you'll breeze through that file. So today, with the exception of that one Excel function, what we want to do is go through some problems that I would expect you would know how to solve at this point. So I'm not going to say that this will be helpful for the final, but well, you're here for a reason, right? So let's get to it. See problem one? Because I want to get through all of these, rather than give you the time to solve it, I'm going to give you the time to set it up. And then we can solve it together. Hopefully you can use these as a study guide for coming up and we'll keep this on your own. Yes. Is this on Scholar? No. What do you think, Ricky?
What?
Should I post this to Scholar?
It'll be on YouTube.
Put it on YouTube. There you go. All right, since I have to switch to an Excel spreadsheet, does somebody have the pertinent information down so I can not have to switch screens? Yeah. Right. Everybody got the basic information? Does anybody find this particular challenge, the problem to be challenging in any way, shape, or form? You had to draw a cash flow diagram of this problem. Could you do it? See some yeses? Yes. Annual percentage rate. Excellent question. It is the same as MAR, however, it is specific to annual. The A is the important point here. And since no other information is given regarding compounding, we can assume that it's compounded annually. APR means annual percentage rate. Same as MAR, compound annual. And when you're dealing with your MAR, you're dealing with annual compounding. Yes? For the second half of the question, yes. So the first part of the question, you just assume annual compounding. So you have a $5,000 deposit at time 0, nothing in years 1, 2, and 3, and then a $2,500 withdrawal at 4, nothing in 5, $2,000 withdrawal in 6, nothing in 7, and the question is asking what's sitting in your account at the end of 7. So you want the future value of that cash flow in year 7. So I would put the 5,000 as a negative value in year 0. I would put my withdrawals as positive values in year 4 and 6. If I were to use my methodology, I'd put that in a column of 8 rows, 0 through 7. And I would find the net present value using the NPV function. And then I would find the future value of that net present value. To do it the way you've been shown in class, just use the mathematical formula to move each of those values forward 7 years. Well, respectively, 0 to 7, move 4 to 7, and 6 to 7. subtract your withdrawals from your initial deposit, and that's your future value. Does that make sense to everybody? Let's bang it out real quick. And nothing there. So Cookie's way, take that value, multiply by 1 plus, what was my rate? 5%? And I'm going to raise that to 7 minus that cell. Y'all know why I do it that way? 7 minus the year that I'm in allows me to be able to drag that formula down. 7 minus 0, minus 1, minus 2. So what this number represents, if I put $5,000 in the bank at 5% for 7 years, I'll have $7,000 at the end of 7 years. That's what that number represents. If I put $2,500 in the bank at the end of year 4 and let it sit for 3 years, I'll have $2,894. That's what that number represents. So all these numbers have been moved to future value. They're all in year 7. I can just take the sum. Doesn't quite add up, does it? How about 7,000 minus, what's that? Well, it should be a negative. Oh, yeah, thank you. Early yet. So, because it's showing negative, I'd have $2,000 left in my account at the end of year 7. That's good. So the other way of doing it would be to use the net present value formula, which I'm going to do underneath here, equals NPV. My rate was 5%. And I need the range of cells that I'm concerned with, that's these. And then I'm going to add to it my value from year 0. Dollars. That's basically saying that this series of cash flow is equivalent to $1,400 in the bank right now, without any withdrawals. But that's not what I'm asking. I want to know how much is left in my account at the end. So I'm going to use my future value function. Rate is still 5%. Number of periods is 7. I'm not making any payments on this. And there's my present value. And a match. Another bracket. You saw something like this on the final? Would you understand and be able to solve it? This is the communication portion of our show. This is where you respond in a positive or negative fashion. Yes, go ahead. I can't hear you.
Can you go to
The future value? B9, net present value. Net present value finds the present value of a series. So it's equals NPV with the rate, and then the series of cells you're looking for from 1 through, not from 0. It takes those values and brings them all back 1 year prior to the start of your series. So if I started at 1, it'll bring it back to 0, which is good. If I start at 0, it'll bring it back to a year before when we're starting, which is not. Again, if you're uncomfortable with any of these formulas I'm showing you, I do not recommend you use them. Don't get to the final and then not know how to do this stuff. Find the way that's most comfortable for you.
What was the question again? Did this answer?
If you put 5,000, actually, you should know that by the cash flow diagram. Based on the diagram, B1 through B8.
Yeah, I can tell that, but what's the second column?
Oh, I did it two different ways.
Oh, okay.
In the second column, I simply moved the money forward 7 years. I found the future value of it.
Of each individual.
Yeah, and then I took the sum of that. Once all the values were in the same year, I could add and subtract the money. And it gave me what I would have in the account. Good. All right, so the second part of the question was, what if the interest was compounded monthly and not annual? What would change here? Exactly. What would the number of time periods be? 12 times whatever I've got, exactly. So doing it my way with the net present value in that situation probably wouldn't be efficient. I'd have to, what's 12 times 7? 84? I'd have 84 rows. That's too much to print. And you'll have room to do it if you want, but why would I want to do that? So in that situation, it would be more advantageous to simply use the formula. And instead of moving it 7 minus A1, I'd move it 84 minus. And what's the other thing that I'd have to do? Change the time period is 1. Change the interest rate. How do I do that? Divide by 12. That's it's important that the interest rate matches the period. If we're dealing in months, then you need to have a monthly rate. And I did not give you a monthly rate. Good? Do we need to do that one, or is that good to go? All I heard was good. Let's move on. All right, so the second one is similar in nature. Almost identical, quite frankly. I threw the washing machine in there just to give some item that you need to purchase. But honestly, it applies to absolutely anything. You're either going to finance something over time, or you're going to save over time. And you can decide which is the more advantageous decision. The information is given there. If you finance it, you know what the credit card company charges. APR means annual percentage rate. And it tells you how often their interest rate is compounded. And the question is, what will your monthly payments be? So my period is going to be in terms of what? I'm sorry. Yep, it's months. Excellent. Monthly payments, monthly period. Which means my interest rate needs to be in. Good. I didn't give you a monthly rate, did I? Remember way back, like 12 weeks ago, we talked about effective interest rates, going from an annual rate, using a compounding rate, a compounding period, and finding the effective rate. You remember that? You might want to review that. I strongly suggest you review that.
Can we review it now?
Yes. I will review it right now. So, effective rate. The actual formula is 1 plus R over M. All of that raised to the n, and then subtract off your 1. The R is my rate that I'm given. The M is the number of times it compounds from the time period that I'm given to the compounding period. In this case, we said daily. Compounds daily. How many, and I could give you an APR, annual rate, daily compound. Question you ask yourself is, how many days are there in a year? 365. And that's what we use, 365. So the rate would be 22% is what I gave, divided by 365. Then the N is the effective period. So I'm looking for monthly. I've reduced it down to a daily rate. How many days are there in a month? And we'll use 30, regardless of February or anything else. So I would raise it to the 30th, and that gives me my effective monthly rate. And this is how I remembered it. So I get my R period, and that's year. Then I get my M period, and that's days. Set days. And then I ask myself, okay, how many days are there in a year? Once I've got it on written down, oh, that's easy. There's 365 days in a year. Then I ask myself, what am I looking for? It was monthly. I got it down to a daily rate. How many days are there in a month? 30. Now I know my R, my M, and my N. And then I just plug those values into that formula.
Is that to the n minus 1 or to the n?
To the N minus 1. The 1 plus gives you a number that you can exponentiate. If you don't have 1 plus in there, what you'll end up doing is exponentiating a fraction, which means it's going to get smaller and smaller and smaller, which is not. So that won't work. So you have the 1 to give you a base so that it can grow. Then we have to subtract that 1 back out. And what you're left with is the actual. Make sense? Okay. So let's go ahead and plug that in. Equals 1 plus 22%. You don't have to use the percent symbol. You can do 0.22. Right about 365. And do the 30. And subtract out the 1. So, 1.8% per month. Does that sound about right? Easy way to check that. You multiply that by 12, would that get you close to 22? Yeah. 2 times 12 is 22, right? So, you can just quickly check yourself and make sure that that's right. So what did I ask? I asked what would the payments be if you wanted to pay it off in 24 months. We were talking monthly. And I gave you the time period, and now we've calculated our interest. So we really want equals PMT. And here's our rate. And our number of periods was given in the question is 24. And the present value is the purchase price of whatever it was. Whatever the item was. Car, machine, washing machine, whatever. So what did I put that down as? Anyone have that? No. No. Well, that costs, and it looks like I didn't finish. There we go. My bad. So it costs $1,000. Put it in as a negative. Remember, that's an outgoing expense. future value. So, if we put it on a credit card, pay this thing off in 24 months, we'd have to pay us, we'd have to give them $51.82 a month. Is that pretty clean? Absolutely. This is using the PMT function. You can also use the geometric series formula that Cookie gave you.
I think this might be better for them.
I'm sorry? That, yes. So the simplistic way to explain it is if I can give you $100 now, I can give you $10 a day for the next 90 days. And it's the same, right? You do that very quickly because you can divide 100 by 10 and you know that the equal payment period would be $10. But we don't deal with dividing that way because that negates the time value of money. There's no interest calculated on that. The payment function includes the interest in that calculation. So if I need to break up the value of something into a specific time period, constant value, I would use the payment function.
Why do you use 2 years or 21 months?
I think it was just given in the problem. I made it up. Because you want a nice front-loading washer.
The equation, like the payment equation says, present value, right next to the future value. The difference, like they have to all have a simple way. We have future value, present value.
Yeah, you can still use it as a future value. That's a different question. Let me come back to that. So the $1,000 was given in the question. Obviously, I overlooked it initially. And I said in the question that what will your payments be if you want to pay it off in 24 months? So I gave you the time period of 24 months. I gave you the APR, annual percentage rate. I told you the compounding period. And I told you that you were going to make monthly payments. It's your job to infer the rest. It's not really inference. Given that information, you should know. Okay, I'm looking at monthly payments. That's the first critical piece of information. If I'm looking at monthly payments, then my interest rate has to be in terms of months. So your next task would be, okay, how do I get to a monthly rate? Use the effective rate, which we just covered, right? Then, whether you use a payment function or a geometric series, you need to calculate what that payment is over that period of time. All right, we clear on that? The second half of the question is, instead of putting it on the credit card, what if we saved $50 a month for the same period of time in a bank account that pays 2% per year, compounded monthly? Find the monthly rate. How do I do that? Right? The nice thing about this part is I'm not having to go down to a lower, the compounding rate is the same, the compounding period is the same as the period we're looking for. So if you plug that into the formula, you would have 2% per year divided by 12 months, and then raised to, and it compounds every month, and we're looking for months. How many months are there in a month? One. Well done, sir. So you raise it to the 1. What happens when you raise anything to the power of 1? Nothing, nothing, nothing at all happens. So you simply need to divide by 12 at that point. So 2% divided by 12 gives us what, 0.05? Is that right? No, that's not right. Whatever it is. That becomes our rate. So we've got, let's get our rate, 2% divided by 12. And I'm looking for how much money will I have if I follow this savings plan for 24 months. So what kind of value am I looking for? Future value, good. Why do I use my future value formula? Here's my rate. What's my number of periods? 24, good. Am I making payments? I see one nod. I see two nods. 3, 4, 5, all right, good. Is there a present value in this particular situation? No, very good. Now that's going to come up as a negative value because I put the payment in as a positive value. But I'm depositing that money in the account. And what did I say about point of origin? What do you use for point of origin? Your pocket, your hand, you. Is that money coming into me? No, it's going out. It's my bank account. It's not like I'm losing the money. I just need a direction for it to go. So Cookie's my banker. I'm handing him my money, and I'm trusting that he's not running back in.
Bad choice, Shawn.
I trust you, Cookie. So let's do it the right way. That is money coming out of my pocket, so that would be a negative value. So if I follow this savings plan, I'm going to have $1,200 at the end of the 24 months. And I did that by putting $50 away, or I can pay the credit card company $51.82. At the end of the 24 months, if I go with the credit card, what do I have?
The machine.
A machine. Good. I owe them nothing, and I have a washing machine. If I go with my savings plan, at the end of 24 months, and I buy the washing machine for cash, there's $1,000 for the washing machine. What do I have?
But you also have 2 years without a washing machine.
So I have a washing machine and $223. Which option is better?
Credit card. The credit card one.
You don't have a washing machine for 2
Yeah, you
years.
have a washing machine for 2 years.
Okay.
I mean,
That's actually a fair assessment. Strictly financially speaking, the savings way, I end up with a little bit more money. But you're right, I don't have a washing machine for 2 years. And we're only talking a couple $100, and so it's not a huge difference. You start talking about higher ticket items, and you'll want to be able to look at this a little more clearly. For purposes of this class, we're dealing in finance. So what answer would I expect from you? Option 2, saving. Was there a question? Yeah. The 1,200?
Yeah.
There is no present value in this case. It's and there is no future value. It's just I'm using the future value formula. Now there would have been a present value if I started with an initial deposit and then began making periodic payments. But I did not. I just made periodic payments.
What's the negative?
What's the name of what?
The negative 50.
That's the PNC, the payment. That's a payment is a constant value that happens over a specific time period, like every month. And in the question I said, what if you save $50 per month? That value never changes, and it's every month. That's a payment. So I can use that in this form. All right. So, here you've got some options. You're considering something. Doesn't have to be for a company. Doesn't have to be manufacturing equipment. It's basically, these are the projections based on what I'm considering doing. And I have these three options. I can buy this guy, it's gonna cost me this much per year, and my projected revenue is this much per year, and when I'm done with it, it's gonna be worth this much, and I can dispose of it. This is the information that I need to make an informed decision about which direction to go. Useful life in years, are they equal? So, can we compare these projects using the present worth under these circumstances? No. What would we have to do? No. But good call. Say again? Present worth, still no. Future worth is still no. So what does A say? Find the annual worth. The million-dollar question, why the annual worth? We did some with unequal lives in class. What did we do with that in that situation? We found the least common multiple, exactly. Once we did that, we were able to find the number of years where they were all equal. Then we could use present worth or future worth. But what did we assume in order to be able to do that?
Repeatability.
Repeatability, exactly. It basically means we're going to buy this thing, we're going to use this thing, we're going to sell this thing, and the very second we sell it, we're going to buy another one. And we're going to repeat this process over and over and over. So, let's see here. Is that a question? No? Okay. So, over 7 years, what I'm going to do here is just go down 7 real quick. None of these should be dollar values. All right, so what happens in year 0? I buy. What's my revenue minus my expenses? 375 minus 220, 155. So we agree that that is my net revenue? And then at the end, I sell it. So I have my revenue for that year plus the sale. Agreed?
How'd you get 145?
Should be, what? 155? Okay. Apparently my head math is not working so well this morning. So that should be 455 then. Okay, so now we agree? Okay, what I want to show is, y'all still see this? If I back that down a little bit. This is what I'm going to do. I'm going to find the annual worth of this project using the payment function. That revenue is the same every year, right? That makes a payment. I have a present value, what I paid up front, and I have a future value, what I can sell this machine for at the end. I have all the pieces of the puzzle that I need to find the annual worth. Payment and annual worth, same thing. So what was the MAR that I gave on this one? Was it 8%? 12%, thank you. Number of periods is 7, right? And present value is that guy there. Payment is that guy there. That's my revenue, that's money coming in. So that'd be a positive value. And then finally, my future value, I said I could sell it for $300,000. This project is worth $142,000 a year. That's the annual worth of this project. Yes, this is the PMT function. It requires the rate, the number of periods. In this case, I had a payment value. I'm sorry. Yeah. Let's do it again. Equals PMT. Yeah, I botched that, didn't I? I'm doing a horrible job with you guys this morning. Yeah, the payment is the payment. The 155 already is the payment over 7 years. So the same way we use net present value and we added the present value to that formula, what I needed to do was I needed to convert the present value and future value to a payment and add the current payment value to that. So let's do it again, let's do it right. 12%. Number of periods is 7. Present value is my upfront cost. Future value is the $300,000 that I sell it for. No type. That's converting this guy here, present value, and the $300,000 that I sell this for into equal payments over 7 years. Now, I add that value. What's that? Now I have the annual worth of this project. If I assume repeatability, that means I need to buy another machine right here. Right? And I start the whole process all over again.
You got time?
Yeah.
I didn't cover annual worth in class. How many of you here are comfortable with that idea? The annual worth. Do you understand why Shawn is using that tactic? Coming in?
Because the question asked for the word.
Do you have time to just quickly go through it for 2 minutes or so?
Yeah.
The annual worth? That'll be great.
Okay, well, that's kind of what I'm doing right here. I'm showing the repeatability, and what I'm going to show you is that by repeating the same thing, that the annual worth of the project actually doesn't change. We're going to increase the time period. We're going to repeat the same values, but the annual worth of the project is going to remain unchanged.